The topic for this video is acids and bases. The essential questions are: what is pH and pOH? How do you calculate pH? And how is the pH related to hydrogen concentration? So this is the pH scale. So 7 is in the middle. It goes from 0 to 14. Anything less than 7 is considered acidic. And the further away you get from 7, the more acidic it is. Okay, 7 is neutral, like water. Anything above 7 is going to be base, or in this diagram they call it an alkali. And so anything, again, further away from 7 you go, the more basic you're getting. So pH is a measure of the hydrogen or H3O plus ion concentration, and you find the pH by taking the negative log of the concentration, and that's going to be in molarity with the square brackets there. The source of the H plus is coming because water has a tendency, when it's in solution, to ionize. So what that means is if you have two water molecules, one's going to give the other one of its hydrogens, and then it becomes H3O plus on one of them and OH minus on the other one. So the one has the extra hydrogen. That extra hydrogen, that's called hydronium when it has 3 hydrogens, and the OH we should recognize as being hydroxide. So another way to think about this is that hydrogen is just breaking apart, but when it breaks apart it only releases one hydrogen and it keeps the other one as a hydroxide. Because of this, hydrogen, H plus, and hydronium, H3O plus, are more or less going to be interchangeable when we're talking about how acidic something is. So you can think of them as being pretty much the same. So we have an ionization constant for water, and it's called Kw, and this can allow us to figure out the concentration of either the hydrogen or the hydroxide in the solution. So Kw is equal to the hydrogen concentration multiplied by the hydroxide concentration, and again, both of these are going to be in molarity. So the Kw is always the same number. It's 1 times 10 to the negative 14th, and that'll be on your star chart. What that means is if one of these goes up, the other one has to go down because it always has to equal the same number in the end. So usually you'll be given one of the concentrations most of the time, and you'll have to divide to find the other one. However, we're going to do a different kind of problem right here. We're going to look at the pH of pure water. So pH we know is negative log of the hydrogen concentration, but we don't have that right now. However, if we look at this Kw, if it's pure water, there should be equal numbers of hydrogens and hydroxides, because when you stick them together, they make a water. So that means they should be the same amount if it's pure water. And so if they're multiplied by each other and they're the same number, that's going to be x squared. And we're plugging in the Kw number there. So we just take the square root, and we get the x is equal to 1 times 10 to the negative 7th. So that's going to be both the hydrogen concentration and the hydroxide concentration. So then if I want to find the pH, I take the negative log of 1 times 10 to the negative 7th, and that's going to give me a pH of 7, which is neutral, which is supposed to be pure water. Okay, let's look at a different type of problem with a different solution. It says calculate hydrogen concentration of a solution if hydroxide concentration is 1 times 10 to the negative 12 molarity. So 1 times 10 to the negative 14th is my Kw. I don't know my hydrogen, so that's going to be an x, and hydroxide is 1 times 10 to the negative 12. So I'm going to divide both sides by 1 times 10 to the negative 12 to solve for x. It's going to cancel on the right. I divide out on the left, and I get 1 times 10 to the negative 2nd molarity. And if you think about your scientific notation, that 1 times 10 to the negative 2nd is actually a much bigger number, which means we have more hydrogens, which makes this an acidic solution. Okay, let's look at another problem. We'll calculate OH if H is 0.25 molarity. So we still have Kw as 1 times 10 to the negative 14th equals 0.25 times x. We're going to divide both sides by 0.25. It's going to cancel on the right. And when we divide, we get 4 times 10 to the negative 14th, which is much smaller, so again we have more hydrogen, so it is acidic. Now we're going to do some pH problems. We're going to keep some equations in mind. pH is the negative log of the H concentration. There's also something called pOH, and all you do, it's the same process, it's just the negative log of the OH concentration this time. If you take the pH and the pOH and add them together, you're going to get 14. So sometimes you can use this method to help you find the pH. And we also still know that Kw is equal to the hydrogen times the hydroxide concentrations. So we're going to be asked to find the pH. So on the first one, remember that hydronium ion H3O plus is interchangeable with H plus. So we're going to do negative log of 1 times 10 to the negative fifth. When we plug that in, we get 5. On the next one, we have negative log of 1 times 10 to the negative 10th. Plug that in, we get 10. On the next one, we have 0.01. Take the negative log, and we get 2. And on this last one, we get negative log of 1 is 0. So that's the most straightforward way to find the pH. Okay, on this next part, let's say they don't give us something quite so straightforward. They give us the OH concentration. There's a couple ways to go about this. We could use the Kw number to get the H and then do the negative log, or we can do it another way. We can take the negative log of that OH, so negative log 1 times 10 to the negative 8. That's going to give us the POH, which is 8. Then, to get the pH, we can just subtract from 14. So 14 minus 8 gives us 6. The next one, we take the negative log of 0.001. That's going to give us 3. And we subtract from 14, so the pH is 11. The next one, we take negative log of 1 times 10 to the negative 14. That gives us 14. Subtract from 14, so then we get 0. And the negative log of 0.01 is 2. And subtract from 14, and that gives us 12. Okay, a little more practice finding the pH. On this first one, we have H is 0.5, so we're just going to go back to doing the negative log of 0.5, and that gives us 0.3. Next one, H is 2.8 times 10 to the negative third. Take the negative log, and that gives us 2.55. On the next one, we have OH now, so we're going to go back to doing what we were doing at the top of the screen. We're going to take the negative log and then subtract from 14, so we get 0.12 with the negative log, subtract from 14, and we get 13.88. On the last one, we get, 5 times 10 to the negative 7th. We're going to take the negative log and subtract from 14 because it's the hydroxide concentration. Negative log gives us 6.3, and then subtract from 14 to get our answer, which is 7.7. Okay, now we're going to work backwards. So if you look on your calculator, the opposite of the log is the same key, but you're going to use the inverse, and that's 10 to the x. And you're going to have to make the number of the pH negative. So if we have a pH of 2, we're going to take 10 to the x of negative 2. And that's going to give us 1 times 10 to the negative second, and that's going to be in molarity. pH of 7, we do 10 to the x of negative 7. And we get 1 times 10 to the negative 7th. 4.62, we do 10 to the x negative 4.62, and we get 2.4 times 10 to the negative 5th. On 8.8, we do 10 to the x negative 8.8, and we do 1.58 times 10 to the negative 9th. Next, we have pH of 1.5, so we do 10 to the x negative 1.5, and we get 0.032. Now, if we look at these last three, they're not the pH, but rather they're the POH. So we're going to have to find the pH first, and we just do that by subtracting the number from 14, and then do the 10 to the x step. So POH is 0, so that means the pH is 14, and then I do 10 to the x of negative 14, and I get 1 times 10 to the negative 14th. On POH is 5.5. I'm going to subtract first from 14, and I get 8.5. And then I do 10 to the x of negative 8.5, and I get 3.16 times 10 to the negative 9th. The last one, I have 11.3. I'm going to subtract from 14 first because it is the POH. I get 2.7, and then I do 10 to the x of negative 2.7, and that gives us 2 times 10 to the negative third.